In this video, I will prove the lever rule. So first, let's look at this phase diagram of benzene and toluene. The horizontal axis is the mole fraction of benzene from 0 to 1. Over here we have pure benzene, over here we have pure toluene. The vapor pressure of pure benzene is roughly 92 torr. The vapor pressure of pure toluene is roughly 35 torr. When the system pressure is high, we can see both benzene and toluene are in the liquid phase. When the system pressure is very low, both benzene and toluene are in the gas phase. In between, there's a region here. In this region, both benzene and toluene coexist in both the liquid phase and the gas phase. Let's look at this point B. If we look at point B, we can see the mole fraction of benzene is 70%. That means overall, in the liquid and gas phase, we have 70% of benzene and 30% toluene. But B is not really a single phase. B is a combination of the liquid phase and gas phase. So if you draw a horizontal line parallel to the horizontal axis, you will be able to see the mole fraction of benzene in the liquid phase, roughly 65%. And over here, this is the mole fraction of benzene in the gas phase, roughly 92%. Again, B, over here, 70%, is between the mole fraction of benzene in the liquid phase and the mole fraction of benzene in the gas phase. Let's amplify this region. So we got this. This L stands for liquid, V stands for vapor, and actually L and V are the mole fractions of benzene in the liquid phase and in the gas phase. B is the overall mole fraction of benzene. So now let's prove this lever rule, which states BV, this segment BV, over LB, this segment LB, is equal to the number of moles of liquid over the number of moles of vapor. This TOT means total. That's the number of moles of benzene plus the number of moles of toluene in the liquid phase. On top. On the bottom, we have the number of moles of benzene and the number of moles of toluene in the gas phase. And this is called the lever rule. So we'll prove this. First, we need to know that, again, L, B, V are the mole fractions of benzene in the liquid phase, in both phases, and in the gas phase. Now we know that if we have the number of moles of liquid plus the number of moles of gas, we get the total number of moles. That's here. The total number of moles of both chemicals in the liquid and gas phases times B gives us the number of moles of benzene. So on the left-hand side, you have the number of moles of benzene. On the right-hand side, we will also have the total number of moles of benzene. Benzene exists in the liquid phase and gas phase. In the liquid phase, this is the number of moles of benzene. The number of moles of liquid times the mole fraction of benzene in the liquid. And then in the gas phase, we have the number of moles of the gases times the mole fraction of benzene in the gas phase. So both sides are the number of moles of benzene in the entire system. And then we can reorganize this equation. We look at this N liquid and N vapor. We put N liquid on the left-hand side, N vapor on the right-hand side, and then we have this equation. B minus L is simply the segment LB over here. V minus B is the segment BV. And then we have this equation, and it's clear now. BV over LB equals N liquid over N vapor. So this is the lever rule for a binary solution. And qualitatively, we can see this B in this phase diagram is closer to L. Therefore, we can take a guess that the number of moles of liquid is more than the number of moles of gas. And also, by using this lever rule, we can see the number of moles of liquid over the number of moles of gas is BV over LB. And we can tell that BV is longer than BL. Therefore, we know that there's more liquid than gas.